So we'll start there with the 2018 paper 2 question 9. Okay, it says find the volume of the solid sphere of radius 0.3 centimeters. Give your answer in centimeters cubed, correct the 3 decimal places. So the first thing we're going to note there is that they're looking for the volume of a sphere. It's of radius 0.3, and they want the answer in centimeters cubed, and they want 3 decimal places. Okay, so the first thing we're going to have to do is we're going to have to look at the log tables. So if you look at the log tables there on page 10, you'll see that the volume of a sphere is 4 over 3 pi r cubed. Okay, so the volume of a sphere, V stands for volume, V represents the curved surface area, V represents the volume. Okay, so volume is equal to 4 over 3 pi r cubed. So we can put that in. So the volume is equal to 4 over 3 pi r cubed. So 4 over 3, like I said, pi r cubed. Okay, all we need to do now is we need to put in the numbers. So we're looking to calculate the volume, so we can just fill in the numbers, and the numbers in this case is going to be r. So instead of 0.3, I can put in, instead of r, I can put in 0.3, I should say. So that'll turn into 4 over 3 pi. We're going to use the pi button on the calculator, and r cubed is going to be 0.3 to be cubed. And if we type that into the calculator, we should get an answer of 0.113, 0.97. Okay, they wanted to correct 3 decimal places. So if I want to correct 3 decimal places, the answer I'm going to give is going to be correct 3 decimal places, obviously. So go back 1, 2, 3, draw your line, look at the number that follows. If that's 5 or greater, we round this digit here up, but in this case it's 0, so that's less than 5, so we just round it off, and the answer would be 0.113. So 0.113, and again the units there for centimeters cubed because it's given in the question. So it gave us there, give your answer in centimeters cubed, and that's our answer there in centimeters cubed. I'm just going to tidy up that 3. So 113. If you've gotten that far, that was actually worth 10 marks in the marking scheme that year. So part 2. The sphere is made of pure gold. Each centimetre cubed of pure gold weighs 19.3 grams. Okay. Find the number of grams of pure gold in the sphere. Give your answer correct 2 decimal places. Okay. So that's a very straightforward one there. So all we need to do is we need to take our 0.13, okay, which is the volume of the sphere, and we need to multiply it by 19.3. Okay, and if we do that, we'll get 2.1809. And again, they asked us to round that to 2 decimal places. So we need to go back 2, 1, 2, draw a line, look at the number that follows. In this case, it's 0 again. So the answer there would be 2.18. Okay, so the answer there would be 2.18. And that there is in grams. If you got that much correct, there was actually 5 more marks going for that. So part 3. It is known that there is approximately 6.2 by 10 to the power of 23 atoms in 197 grams of pure gold. Okay, so there's a certain amount of atoms in a certain amount of grams. Find the number of atoms of pure gold in the sphere. Okay, so we know how many grams the sphere is. Okay, we worked it out in the last part of the question. Give your answer in the form of a multiplied by 10 to the power of n, where a is less than or equal to a, or 1 is less than or equal to a, which is less than 10. where A is correct, two significant figures. Okay, so they're giving us a lot of information there, so we'll just have a look there and see. So what they're trying to do is they're trying to get us to find how many atoms there is in a sphere. Okay, so we'll just highlight that because that's important. That's what they're trying to get us to do. Find the number of atoms of pure gold in the sphere, right? Atoms in the pure gold sphere, right? So this is also important. And standard form, they want the answer in. And A has to be between 1 and 10. And two significant figures. Okay, so we've highlighted the key information. We also know what we're dealing with. So the sphere that we're dealing with is equal to 2.18 grams. Okay, so what I'm going to do is I'm going to put the grams on one side. So I'll put the grams all on the left hand side and I'll put the atoms on the right. So I know that there's 197 grams is equal to 6.02 all multiplied by 10 to the power negative of 23. Okay. If I can find out what 1 gram is, then I'll be able to find out what 2.8 grams is. I'll just spread them out actually. Okay, and it's that simple. The challenge here is that we're dealing with standard form or scientific notation, but the actual process is actually very straightforward and we can get our calculators to do the majority of the work here. So, to turn 197 into 1, we simply divide it by 197. So we'll do the exact same on the other side and divide that by 197. So that'll give us 6.02 all multiplied by 10 to the power 23 all over 197. Okay, the next step there is how do we convert from 1 to 2.8? And it's very simple, we just multiply by 2.18. Okay, because we did it on the left hand side, we have to do it on the right hand side. Okay, now all we need to do is we need to take this and we need to multiply it by 2.18. So 2.18 all multiplied by 6.02 multiplied by 10 to the 23 all over 197. And that there looks complicated, but it's not. All we need to do, as I say, is type it into the calculator. So if we type that into the calculator, we'll get an answer of 6.66. Okay, so this here turns into 6.6617258888 all multiplied by 10 to the power 21. Now, in the question, just be very, very careful. It asked us to round two significant figures, okay? When it asks us to round two significant figures, that means that you're only going to include two figures. So if we count back two figures, that brings us to here. So we need to look at that and think, does it round off or round up or round off? And in this case, it rounds up. So the answer in this case will be equal to 6.7 all multiplied by 10 to the power 21. And if you had wrote that, you would have got 5 marks for that question. So, next we've got part B. A survey was carried out on behalf of a television station to investigate the popularity of a certain show. A random sample of 1,560 television viewers was surveyed. Find the margin of error of the survey. Give your answer as a percentage correct to one decimal place. So, we know that a margin of error is equal to 1 over the square root of n. Okay, and in this case you need to know what n is. N is equal to the sample size. So in order to find the margin of error, all we need to do is we need to say 1 over the square root of the sample size, and in this case the sample size was 1,560 people. And if you type that into the calculator, you'll end up with a value of 0.025318. Okay, so 0.025318. And they wanted us to give our answer as a percentage. So to convert that to a percentage, what I need to do is I need to multiply it by 100. Multiply by 100. And that will give us, if we multiply it by 100, we'll get 2.5318. And they asked us to give our answer correct to 1 decimal place. So the answer in this case will be correct to 1 decimal place. So go back 1, draw your imaginary line and see what follows. So the answer in this case, and I'm going to have to put the answer down there. So the answer in this case was equal to 2.5. And that year, if you got that much out, you achieved 5 marks. So the next one there is, in the survey, 546 of the 1,560 viewers surveyed said that they liked the show. Okay, so you can see there, this time 546. So roughly we can say a third of the viewers liked the show. Use your answer in part 1, okay, so the margin of error above to create a 95% confidence interval for the percentage of viewers who liked the show. So the 95% confidence interval comes up a fair bit on the exam, typically worth about 5 marks, and it's very, very easy to do it, right? All it is basically a measure of how accurate your data is, okay? So you take a proportion out of your sample, okay, and you form a sample proportion, okay? So the sample proportion is typically referred to as p hat. Okay, so that's just a p with a little hat over it. And p hat is where you take your sample proportions. That's 546 out of 1,560. Okay, so that's our sample proportion, right? So you can see from that suggests that approximately a third of the viewers liked the TV, whatever is the TV program, whatever it was that they were testing, right? What you need to do is you need to convert that to decimal. So if we type that into the calculator, we'll end up with 0.3 or 0.35 even, right? And if we were to write that as a percentage, it would be equal to 35%. So at the minute, this sample tells us that approximately 35% of the people like the film, okay? Now, what a confidence interval does is it creates an interval of 95%. So it tells us an interval that highlights how accurate this data is. So what you need to do is we need to create an interval that this falls into. So I need to get the upper limits and the lower limits, okay? So how I do that is very simple. We just say p hat minus the margin of error, comma, p hat plus the margin of error. So that's going to be 35 minus 2.5, comma, 35 plus 2.5. Okay, so that gives us our confidence interval of 32.5 and 37.5. Okay, now that there would have got us 5 marks, and I'm just going to explain to you what that actually means. So what that actually means is that that's how accurate this data is. So if you were to sample, we'll say we only have a sample there of 1,560 people that were surveyed. If that sample was 20,000 people, we would still expect between 32.5 and 37.5 of the people surveyed to say that they liked the film. Okay, so does that make sense? So all we're doing is this was for our sample, but our margin of error just tells us that we expect between 32.5 and 37.5 of people to like the film. Okay, so it's just giving you an error either side of rather than just sticking to 35%, it's allowing for a little bit of wiggle room to the left and right for people that like the survey. Okay. So, part 3. An executive for the television station had claimed that 40% of the viewers liked the show. Use your answer from part 2 above to conduct a hypothesis test at 5% level of significance. To test the executive's claim, state your null hypothesis, your alternative hypothesis, and give your conclusion in the context of the question. Okay, so what we need to do there is we need to start with a null hypothesis, okay? And we can see there that the claim here is that 40% of viewers like the show. So that can be our null hypothesis. So H0 is equal to 40% of viewers liked the show. Okay, that's one hypothesis. We also need to put in an alternative hypothesis. So an alternative hypothesis would be that the viewers who liked the show, viewers that liked the show is not equal to 40%. So it does not equal 40%. Okay, so that's our two hypotheses. Hypothesis 1 is that 40% of viewers liked the show. Hypothesis 2 is that 41% of viewers did not like the show. Okay, so we need to look at this and see how this fits in with our confidence interval. So we found that 32.5 and 37.5 was our range for people who like the show. So we can see there that 40% is going to be outside that. So 40% is going to fall outside the confidence interval. So we can't accept that the hypothesis is true, the null hypothesis is true. So we just need to write down that claim. So we cannot accept the null hypothesis. And that would be our conclusion there. If we had done that, the conclusion, I suppose we can put in a conclusion there as well. And the conclusion could be that the percentage of viewers who like the show is not equal to 40. So we can put in our conclusion there that the percentage of viewers is not equal to 40%. And if we had done that, we would have got 10 marks for that part of the question.